Okay, so we went over all the exponent laws primarily to understand when we need to then apply them to addition, subtraction, multiplication, and division. So when you add polynomials, you don't have to worry about the exponent rules as much as if you were multiplying them together, polynomials together. When you add polynomials, you are only worrying about combining like terms. So like question like number 1, it says, what is the sum of negative 3x squared minus 7x plus 9 and negative 5x squared plus 6x minus 4? So best way to do this would be to stack the like items together. If you're not comfortable with doing arches or with doing boxes or color coding, I know teachers do teach it all different ways. Don't be afraid to use your calculator if you struggle with signed numbers. So I have negative 3 plus negative 5 is negative 8. I am not combining any exponents here because this is not multiplication. If you're multiplying powers with like bases, yes, you multiply them, you add them. When you're simply adding two expressions together that are like terms, all you're worrying about doing is combining the coefficients. Negative 7 plus 6 would be negative 1x, and 9 plus negative 4 would be positive 5. So we get the answer of, not choice 2. What am I doing? Choice 1. Negative 8x squared minus x plus 5. Something like question number 7, I have here the sum of 3x squared plus x plus 8 and x squared minus 9. So put the like items only together. Put a 1 in front of the x squared. And now I can simplify the x squares. I'm going to pull down the x because it's not being combined with anything. And then 8 plus negative 9 is negative 1. So we get 4x squared plus x minus 1, which is choice 1. So pretty self-explanatory when it comes to adding polynomials. Just combine like terms. Right, so I'm going to clear the screen and move down. A question like number 11 here. When you have distribution, you are going to perform the distribution first. So 2 times x squared is 2x squared. 2 times negative 1 is negative 2. So now I have 3x times x. Here we are going to apply product of like bases. 3x times x would be 3x squared, because 1 plus 1 is 2. Now I have 3x times negative 4. So I'm actually going to move the negative 2 over up top to leave a space. 3x times negative 4 would be negative 12x. And there's nothing else being combined. So 2x squared plus 3x squared is 5x squared. Just bring down the negative 12x. And then just bring down the negative 2. So we're left with choice 4 for answer for number 11. So that pretty much is adding polynomials in a nutshell. So what I'm going to do right now is I'm going to pause the recording and I'm going to change the worksheet to be operations of polynomials 2. So when you come back, so when this unblips, and when this kind of comes back, in the next moment will be the next worksheet. All right, so I have changed the document. Now we're going to be talking about subtraction with polynomials. So subtraction with polynomials is done the same way as addition with polynomials. However, you have to make sure that with the subtraction sign, you are distributing that value across the parenthesis. So like question number 1 here says the expression 3 times x plus 4 minus 2x plus 7. So I am going to distribute the 3 across the second parenthesis. And I get 3x plus 12. Now with this subtraction sign, I'm going to treat that like a -1. And I'm going to distribute that -1 into the second parenthesis. So everything in the second parenthesis becomes the opposite of what it was originally because of that -1 between the two polynomials. And now we can simply combine like terms. I have 3x plus 12 minus 2x minus 7. So 3x minus 2x is 1x, 12 minus 7 is 5, and we get choice 1, x plus 5. And of course, the longer the expression, the more there would be to distribute. So like 2 is similar to number 1, 7 is similar to number 1, just with more expressions being present. So I want to do question 4 on the bottom, but let's do question 7 up here. I have 5x squared minus x plus 4. And here, instead of just being -1, there's a 3 in front, so I'm going to distribute that -3 into the second parenthesis. So -3x squared. So -3 times positive x is positive 3x. So again, -3 times -1x is positive 3. -3 times -2, positive 6. And now we combine like terms straight down. 5 minus 3 is 2x squared. Again, not touching the exponents, only the numbers. -1 plus 3 is positive 2x. And then 4 plus 6 is 10. So we get 2x squared plus 2x plus 10. All right, so I'm going to clear the screen. Oh. Let's see what else we have here. So like question 4 is straight just doing the subtraction here. So 5x squared. So again, never touching anything for the first exponent, for the first polynomial, excuse me. You're only taking the negative or whatever is in front of the second one and distributing it across. So like with the one we just did before, number 7 or whatever it was we just did, it was -3. So not just doing a -1 like we would normally do, it's -3. So -1 to 3x squared is -3x squared. -1 to 3x is -3x. -1 to -1 is +1. And then we combine. 5 minus 3 is 2. -2 minus 3 is -5. 4 plus 1 is 5. So 2x squared minus 5x plus 5. And then the kind of the rest of this document is not really necessary for the exam. Oh, wait, actually, question 12, I think I've seen a similar question like that on one of the current Regencies, where, okay, this is like a part 2 question where we're just pretty much doing the same thing we just did with question 4. Make sure you're taking that -1 and you are distributing it across the parenthesis. So again, this is, I would say, definitely like a part 2 question. So I'll do the work right here. So 3x squared plus 4x minus 8. -1 times -2 will be positive 2x squared. -1 times 4 will be -4x. And -1 times positive 2 will be -2. So 3 plus 2 is 5x squared. These end up canceling each other out, become a value of 0. -8 minus 2 is -10. So 5x squared minus 10. So again, the rest of them are pretty much the same kind of result, just making sure you know how to apply that subtraction. So I'm once again going to pause the recording to bring up my next document for operations with polynomials. All right, now I have switched the document to being now talking about how to multiply binomials together. And when we have a situation like this, you'll be using primarily the rule of FOIL, first, outer, inner, last. Or some schools call it double distribution. I learned it using FOIL, and that's primarily how we do it in the college algebra course that I teach. So we use it's first, outer, inner, last. So like a question, not question number 1. Let me see which one would be doing that. Question number 3. It says, what's the product of C plus 8 and C minus 5? So here we are going to perform that FOIL. So the first two get multiplied together. Then the outer terms get multiplied together. Then the inner terms get multiplied together. And then the last two terms get multiplied together. Combine any like terms, which here usually is your outer and your inner terms. And we get C squared. -5 plus 8 is +3 minus 40. So number 3 is choice 1. I didn't notice how there are some more simplistic ones. Like question number 1 is just saying to take 2r squared minus 5 and 3r. That is like distribution. So the monomial is getting multiplied by the binomial. Mono means 1, bi means 2, tri means 3, poly means multi. So here I'm just going to take the 3r and I'm going to multiply it by both items of the binomial. So 3r times 2r squared. 3 times 2 is 6. R to the first times r squared. I use my exponent rule. Add the exponents. 3r times -5. 3 times -5 is -15. The r just gets carried over. So we get choice 1, 6r cubed minus 15r. 2 is another good question. So we're multiplying these two together. So I'm going to distribute the -3x squared y into the second parenthesis of 5xy squared plus xy. So when we have something like this, which is a multivariable monomial being multiplied by multivariable binomial, make sure that you separate your variables from your coefficients. So -3 times 5, that's -15. X squared times x will give me x cubed. Y to ny squared will give me y cubed. Now this plus sign does get carried down. Now -3 times nothing in front of the other one just means -3. So now I'm going to do x squared times x, which is just x cubed. And then y times y is y squared. So I know I have a plus and a minus sign here, but in all our answer choices don't have that. So you can just basically drop the plus sign and then the two parentheses and then bring over that negative as one big minus sign. So -15 x cubed y cubed minus 3x cubed y squared, which is choice 1 once again. So that's how overall you want to do multiplication with polynomials. We have 1 and 2 deal with a monomial by a binomial. Number 3 dealt with the FOIL. A question like number 6, I have an entire binomial being squared. That means to take what's inside that parenthesis and multiply it however many times. So here would be a squared plus b squared times a squared plus b squared. And then we can do our FOIL. A squared times a squared. Here we will add our exponents. A squared times b squared will give me a squared b squared. Just put the two next to each other. Same thing for the inner terms, a squared b squared. And then for the last is b squared plus b times b squared, which would be b to the fourth power. Combine these two together. A squared b squared plus a squared b squared will give you 2 a squared b squared plus b to the fourth power. So don't assume number one is not just taking that exponent and multiplying it in. That's what the product of like bases rule, or the power to a power rule we were talking about before. When you have a plus sign in between, you got to take the entire polynomial, entire binomial, whatever it may be, and multiply it however many times that's represented by the exponent. So we're going to get choice 3 for question number 6. I feel like I might have saw question number 8 on one of the exams. So I'm going to clear the screen and bring it up a little bit so I have a little bit more space to write. Because I'm going to teach you a different way to do this one. You can do like how we were doing before, using a FOIL, use an extension of FOIL, when you have a trinomial being multiplied by a binomial. Some teachers teach it where you take the binomial, multiply it by each item across the first polynomial, then you do the same thing with the second item in the binomial to the trinomial. Now that's all well and good. That's great. You can do it that way. That's like an extension of FOIL. Even further, like instead of being double distribution, it's more like triple no, it'd still be double distribution, but across 3 things instead of only 2. Another way you can do this is I've seen some schools use what they call the box method. So if you learned it that way, that's fine. If you used it this way instead of FOIL, that's fine too. Use the method that you were taught in school that worked for you. If I'm teaching you a little differently, don't feel like you have to change your method of instruction, your method of learning. With the box method, I like the box method primarily whenever I have a trinomial and a binomial being multiplied together. Again, double distribution works just fine, FOIL, whatever you want to call it. It works just as fine. You will get the same answer. It's just going to be not as neat when all your numbers are written out. So when I do box method, I put however many columns or rows necessary. I like putting the trinomial across the top and the binomial across the side. So number of columns matches each item in the trinomial. Number of rows represents each item in the binomial. So then I'm going to multiply by row and column. So x squared times x is x cubed. X squared times 1 is just x squared. Negative 2 times x will be negative 2x squared. Negative 2 times 1, negative 2x. 3 times x to the first is 3x. 3 times 1 is 3. Now you can see how like items are along the diagonals. You're going to combine those like items. Instead of circling them, I'm just going to use lines. So I get, and then the first and the last just kind of carry down. So I have x cubed gets carried down. Negative 2 plus the 1 here is negative 1x squared. Negative 2 plus 3 is positive 1x, and then just bring down the 3. So that will leave us with the answer of x cubed, so not 3, not 4, negative 1x squared, positive 1x plus 3, so 8 will be choice 1. Choice 1. Now, like I said, you could perform double distribution here, and you get the same thing. X times x squared is x cubed. Negative 2x times x is negative 2x squared. 3 times x is 3x, just like we had before. Then you're going to do x cubed times 1 is 1x squared. Negative 2x times 1 is negative 2x. 3 times 1 is 3. So notice how here I stacked them as I went. So I can simply just combine them the same way I did along the diagonals before. And I get the same thing. So you have the control of how you want to answer a question like that. I've seen questions like that in the multiple choice. And I think in one of the Regencies, I saw it as a short answer, like a part 2 question. So that could pop up there. Number 9 is another great question. I don't have all the answer choices being seen, but pretty much what you're doing there is you're doing area. And then it wants you to find the area of a new garden. So you're going to add to the original polynomials and then multiply them. So I'll do question 9 off to the side over here. This is a great question. So Chad has a garden in the shape of a rectangle. Its length is twice its width. Okay, so if width is x, that means length is 2x. So that means the area when I multiply them would be 2x squared. You decide to make a new garden that is 2 feet wider. No, decide to make a new garden that was 2 feet longer and 2 feet wider. So if x was the width of the original, I'm going to do x plus 2. If it's 2x, now it's 2x plus 2. If x represents the original width of the garden, which expression represents the difference between the area of his new garden and the area of the original garden? So when I take the 2x plus 2, multiply by, again, area is the multiplication of the 2. I get 2x squared plus 4x plus 2x plus 4. So my area here is 2x squared plus 6x plus 4. Squeezed it in. So again, I'm just applying FOIL there. Now the question says, what would represent the difference between the areas? So 2x squared plus 6x plus 4 minus 2x squared. So there's no real distribution happening here. All you're going to have to do here is just take the 2 x's and cancel each other out, because 2x squared minus 2x squared is 0x squared. So we're left with the 6x plus 4, which luckily we can see as an option here with choice 1. So I don't know how much something like that will be on the exam, but it is a good application of knowing geometry, the geometric laws, rules for shapes, area, along with that subtraction of polynomials and multiplication of polynomials. So it's kind of all mixed in together. All right, so that brings us to the end of the operations of polynomials that I'm going to cover. So this whole recording dealt with addition, subtraction, and multiplication.